Hello. Today we are going to learn how to use upper and lower bounds effectively in problems. Before I begin with example problems, I'd like to clarify, so how do we, for example, calculate the maximum value of an area, or if you have a formula, the speed and time, how you calculate the maximum possible values. Right, so first of all, you have to look at the formula as numbers. For example, area is the multiplication of length times width. So of course the length has a value, width has a value, multiply them together to get the area. Now, when you multiply two numbers together, in this case, to find the maximum possible values, then the length and the width should be at their maximum values. So you need to calculate the upper bound for both length and width. And to find the minimum possible values, you have to calculate the lower bound for the length and the width, because multiplying to the lowest values, the area is going to be the lowest, and multiplying to highest values, the area is going to be the highest. Let's have a look at the example. The rectangle measures 10 centimeter by 6 centimeter to the nearest centimeters. Find its greatest and smallest area. So it says to the nearest centimeters. I'd like to underline, always underline to the nearest centimeters. So this is the unit that we are going to find the lower bound or measure or upper bound for both of them. So now for 10 to the nearest centimeters, so it's going to be for the length, so upper and lower bound, so for the length is going to be 10 centimeters upper bound, okay, it is 10 plus half of the unit, so it's going to be 0.5, and so it is 10.5 centimeter. Okay, now for the width, again, upper bound, I'm going to call it UB upper bound. It is going to be 6 plus 0.5 equals 6.5 centimeters. All right. And then lower bound for the length, lower bound, it is obviously take away half, so 10, take away 0.5 equals 9.5 centimeter. And width, again, width, lower bound, right, lower bound, it is going to be 6. Take away 0.5 equals 5.5 centimeters. All right, now that we found both upper and lower bound of the length and width, now let's have a look how to calculate the greatest and smallest area. So let's go for the greatest area. So greatest area, now obviously greatest area means you need to find the highest possible value of the area, and so which of these you are going to take to substitute? So you need to take the highest lower bound for the length and the highest lower bound for the width. So you're going to take this one and this one, upper bound, highest upper bound for both of them. So it's going to be 10.5 multiplied by 6.5, and both of them are in centimeters, so multiply both of them together using a calculator. And so the answer is going to be 10.5 multiplied by 6.5. Okay, and then the answer is going to be 68.25 centimeter squared. So this is the greatest area. And the smallest area, of course, now you are going to multiply the lower bound for both of them. So it's 9.5 times 5.5. So 9.5 times 0.5, and then 5.5, and then the answer is going to be 52.25 centimeter squared. So this is how you find the greatest and the smallest area. Now let's have a look at another example formula. We have speed, which is equal distance over time. Now be careful here because it is a fraction, and to get the highest value of the fraction, you need to have the highest value of the numerator, which in this case is the distance, and the lowest value of the denominator, which in this case is the time. So you need the upper bound for the distance and the lower bound for the time to get the maximum value of the speed, and to get the minimum value of the speed. So you need the lower bound for the distance and the upper bound for the time. Let's have a look at the example. It says, Sam runs a distance of 200 meters measured to the nearest 10 meters. His time is 35 seconds measured to the nearest centimeter, to the nearest 5 seconds. Find the lower and upper bound of his speed. Speed, which means lower and upper bound of the speed. Now, let's start with the lower bound of the speed. Lower bound of the speed, which means you need to find the lowest value of the whole fraction, distance over time. So what do you need to find the lowest bound of the speed? Lower bound of the speed, So you are going to need a lower bound of the distance. Okay, distance over upper bound of the time to get the lowest bound of the fraction, of the division. So lowest bound of the distance. Now this is 200 meters measured to 10 meters. So the lowest bound of the distance is going to be 200. So I'm going to write it down up here. Lowest bound of the distance is going to be 200 minus half of the unit, so minus 5. And so the answer is going to be 195 meters, 195 meters. And the upper bound of the time, is going to be now, the time is 35 seconds, measured to the nearest 5 seconds. Upper bound means 35 seconds plus half of the 5, which is plus 2.5, and the answer is going to be 37.5 seconds. There you go. So we have the lowest bound for the distance is 195 meters, and the upper bound for the time, and that is 37.5 seconds. And now what we need to do is just divide them together. So it's going to be equals 195, substitute here, divided by 37.5, and the answer is going to be, so 195 divided by 37.5. The answer is going to be 5.2. 5.2. Now the measuring unit, we divide in meters by second, so the measuring unit is going to be meters per second. All right, this is the lower bound of the speed. Now, upper bound of the speed, I'm going to put upper bound of speed. Then in this case, of course, we're going to need the upper bound of distance, okay, over, so upper bound of distance over lower bound of time, okay, because you need the highest value of the fraction. So upper bound of distance. So upper bound of distance is going to be 200. I'm going to do the substitution here straight away. 200 plus 5. And the lower bound of time is going to be 35 minus 2.5 in this case, okay? And so I'm going to divide 205 meters by 32.5 seconds. And let's see how much that will be. So we have 205 divided by 32.55. Okay, the answer 205 divided by 32.55. The answer is going to be roughly 6.29. So 6.29 meters meter per second, 6.29 meters per second. So this is the upper bound of the speed. So yeah, be careful. The formula is the one that decides. So which one are you going to take, going to consider whether the upper bound or the lower bound. And here you have something to work independently with. It is a problem. Now in this case, again, is a rectangular carpet, measures 8 by 10 to the nearest meters. You need to find the upper and the lower bounds for the perimeter of the carpet first, and then for the area. So the one for the area is similar to the one we just did. Now for the perimeter, remember, the perimeter is different. So look at the formula. What do you need to add? How should the values of what you add be to be able to find the upper bound, so the highest value of the perimeter, and the lower bound? So yeah, just like that. Have a lovely day, and thank you for watching Math Steps. Bye-bye.